This is our second review tape in elementary algebra. In this tape, we're going to be going over our early work in fractions in our elementary algebra courses. We will start by reminding you of the fundamental principle of fractions, which I have written on the board here. If you have a fraction, say a over b, you will get an equivalent fraction if you multiply numerator and denominator of this fraction by the same non-zero constant, same non-zero quantity. For example, I have k here, not 0. So if we multiply top and bottom by the same non-zero quantity, k, we get ak over bk, an equivalent fraction. Thinking about it the other way, if you start with this fraction, ak over bk, if you divide numerator and denominator by the same non-zero quantity, in this case k, we get a over b, an equivalent fraction. So starting with a fraction, you are allowed to multiply top and bottom of this fraction by the same non-zero quantity, or divide top and bottom by the same non-zero quantity, and you will get an equivalent fraction. We will have need to do both of these things in the course of this videotape. Okay, now also when we reduce fractions, okay, you can think of, say, canceling out the k, but what we're really doing, of course, is dividing numerator and denominator by k to get a over b. Since we are dividing, to undo a multiplication, you can only do this when there is a multiplication. In other words, you cannot, say, have a plus k over b plus k and cancel the k's. You can only reduce by canceling out common factors. You cannot cancel out common terms. You cannot cancel the k's here, because canceling is a type of division, and they'd have to be first joined by multiplication. Okay. We'd like to, in each case, reduce to lowest terms the expression that I give you. And in most cases, we'll be using this fundamental principle of fractions. Minus 8x over 6x. Okay, what we're going to do here is to factor the numerator and the denominator so that we can see a common term, a common factor that we can cancel out. And we can think of the numerator as, instead of minus 8x, as minus 4 times 2x, and the denominator as plus 3 times 2x. In other words, we notice that 2x is a factor of both the numerator and the denominator. The x was obvious, and we see that 8 and 6 have 2 in common. Okay, so we now have it in the form, say, ak over bk. Okay, and we can divide numerator and denominator by 2x in this case, or cancel the 2x's to reduce this to minus 4/3. In our second example, also we'd like to reduce to lowest terms. The following: 18 x squared y z to the 6th over 12 x y to the 4th z cubed. Okay, and what I'm going to do here is to break this up into several smaller problems. We can make this 18 over 12. We could think of factoring both the 18 and 12. What factors do they have in common? Well, 6 goes into 12 and into 18. You can, of course, start off smaller. You could say, well, you could factor out a 2. You can, in fact, bring them down to their prime factor. And you could write this as 2 times 2 times 3, and this is 2 times 3 times 3. Okay, or you can just simply say that 18 is 6 times 3, and 12 is 6 times 2. Factoring a 6 out of both. And then let's see, we have the x squared over x. You could think of that as x times x over x. The y over y to the 4th. And the z to the 6th over z cubed. You have a choice. You can either leave it as z to the 6 over z cubed, or actually write out the z's. Let's see what we have. Here, the 6's can be canceled. You're dividing top and bottom by 6, leaving us with 3 halves. Here, the x's can be canceled, leaving us with x over 1. Here, one of the y's can be canceled, leaving us with, when we're dividing top and bottom by y, so you divide y by y, you're left with 1 here. It's not a 0 up there. So it's 1 over y, which is y cubed. And if you don't want to actually write out the 6 z's and dividing by the 3 z's, you can use the fact that z to the 6th over z cubed is z to the 6 minus 3, or z to the 3 power. Or dividing top and bottom by z cubed, you have 1 here, z to the 6 over z cubed, just z cubed. OK, let's combine and see what we have. We have 3x z cubed in the numerator over 2y cubed in the denominator. OK, in doing this, we were actually sort of using the rule for multiplication of fractions, which I would like to state for you. If you want to multiply two fractions, a over b times c over d, you should multiply the numerators and divide by the product of the denominators. A over b times c over d, you multiply the numerators and divide by the product of the denominators, ac over bd. Okay, but in doing that, before you do that, it's sometimes helpful to see if you can possibly do any simplification before this point. If you can reduce before this point, it's helpful. Let's try the following example. And of course, you can use this the other way as well, and that's what we did here. We took this big fraction and broke it up into several smaller fractions. OK, let's multiply the following. (10x) over 3y squared z times 12y over 8xz. OK. You can do your cancellation right on the problem. I don't want to mess this up, so let me rewrite it for you. And while I'm doing that, I may as well try to factor some of these constants. 10 is 5 times 2, x here, 3y squared z. 12, you can make that 2 times 2 times 3y over 8xz. And 8 you can make 2 times 2 times 2xz. Or you could have left 12 as 4 times 3 and 8 as 4 times 2. Now let's see what cancels before we do the actual multiplication. OK, we can divide top and bottom by 2 here. We can cancel this 2 here. And this 2 will cancel that one. This x here will cancel that x there. This 3 will cancel this 3. And this y will cancel this y. And let's see what remains. Remember, if everything is canceled out, that simply means a 1 remains. Now we're going to do, in the simplified form, we'll do the multiplication of fractions. On the top, we have 5 times 1. These are all 1s. So on the top, we simply have 5. And on the bottom, y times z, these are all 1s, times z, y, z, z, or y, z squared. So 5 over yz squared. Try another example. Multiply. 6x squared y cubed over minus 9 z to the 5th times minus 3xz over 2y squared times 1 over x cubed y. Okay, 6x squared y cubed we can write as 2 times 3 x squared y cubed over minus 9, let's make that 3 times 3, z to the 5th. You can actually leave it like that. I'll show it to you both ways. Minus 3xz is factored as far as it goes. 2y squared 1 over x cubed y. Okay, if I'd actually written out the 5 z's in a row here, we would cancel off one. We'd have 4 of them. The same thing can be accomplished in this fashion, dividing top and bottom here by z. Z divided by z is 1. Z to the 5th divided by z is z to the 4th. So that's an alternative to writing out all of the z's. Let's see what else cancels. We can cancel the 3 here and here, the other 3 here and here, the 2 here and here. This x will cancel this. This x will cancel this. Let's see. This y will cancel this. This y will cancel this. This y will cancel this. I see another x up here. This will cancel this. Let's see what's left. Now, we see a minus here and a minus here. Okay, so it's a minus times a plus, so the final answer will be plus. We could think of these minus signs as canceling out. On the top, everything is out except for a 1, so we have just 1 over. And on the bottom, everything is really a 1 here except the z to the 4th, so 1 over z to the 4th. If you want to see this again, you can just rewind me to the beginning of the problem. You can watch me cancel everything out again. By the way, this is 1 over z to the 4th, not just z to the 4th. Canceling everything else does not give you a 0, does not move this upstairs. It's 1 on the top and z to the 4th on the bottom. Okay, now I'd like to give you the rule for division of fractions. It's the same rule for algebra that you had for arithmetic. When you have one fraction a over b and you want to divide by another fraction divided by c over d, the rule is to invert and multiply. A over b divided by c over d means a over b times d over c. A over b, instead of dividing by c over d, we invert and multiply by d over c, giving us ad over bc. So we reduce division problems to multiplication problems. Okay, example number 5. Do the following division. 3x divided by 4y. That fraction divided by 12y over x. Okay, this could also be given to you 3x over 4y divided by 12y over x. It means the same thing. This fraction divided by this fraction. In either case, your next step would be to say, this is 3x over 4y times, inverting and multiplying, x over 12y. So whether you start like this or you start like this, the next thing you do is to invert and multiply. So you're multiplying by x over 12y. All right, let's see what we can do in the way of simplification. You can divide numerator and denominator by 3. 3 divided by 3 gives you 1. 12 divided by 3 gives you 4. Okay, and that's about it. These x's do not cancel anything down here. On the top we have x squared, and on the bottom 4y times 4y, that is 16y squared. Okay, you must resist the temptation to do the cancellation at this stage. Okay, and think that the y's and the x's can cancel. You first invert and then you multiply. All right, in example number 6, it's 9x squared over 2y divided by 18x squared y to the 4th. Okay. Dividing by this really means dividing by this over 1. This divided by this. If you just see like a number 5, it's 5 over 1. This is 18x squared y to the 4th over 1. And then it makes it obvious that what we need is to invert and multiply. When you invert and multiply, you get 1 over 18x squared y to the 4th. Let's see what we can do as far as simplification. We can divide numerator and denominator by 9, and you can divide, in other words, from this numerator to this denominator. It's really one big numerator over one big denominator. Okay, that's eventually what's going to happen. So you can, cancel from here and here. That's perfectly okay. Dividing top and bottom by 9. 9 divided by 9 is 1. 18 divided by 9 gives you 2. Divide top and bottom by x squared. That will cancel that. So let's see what we have. On the top, we have only 1 left. And on the bottom, 2 times 2, that's 4. Y times y to the 4th, giving us y to the 5th. 1 over 4, y to the 5th. In our next problem, problem 7, we have 2x divided by 3y times 5x squared over 4y divided by 5x cubed over 6y squared. Okay. This is straight multiplication. It's the last one that's division, and we'll invert and multiply for that. So 2x over 3y we leave alone. 5x squared over 4y times, inverting and multiplying, 6y squared over 5x cubed. Okay, let's see what we can do. X squared, dividing the numerator by x squared, leaves you with 1. Dividing x cubed by x squared leaves you with x. This x can then in turn be canceled with this one over here. Or you can say x times x squared is x cubed and knock that out directly. Now, let's see what we have. We have y times y, that's y squared, which will cancel that out. Or you could do them one at a time. In other words, dividing this by y, dividing this by y, leaves you with just y, and then canceling that one with that one. All right. Dividing top and bottom by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. 2 divided by 2 gives you 1. 4 divided by 2 gives you 2. And then we can cancel these 2's and these 5's, leaving us with everything having canceled out on top, leaving us with 1 on top, and on the bottom, once again, everything canceled out, a final answer of 1, not 0, but 1. Okay, well, so far we've handled multiplication and division of fractions. we're now going to worry about addition and subtraction of fractions. Okay, here's the rule. For addition and subtraction. If you want to, say, add two fractions that have the same denominator, you combine the numerators over the common denominator. And the same thing for subtraction. A over C minus B over C. A minus B over C. To add or subtract fractions having the same denominator, and that's the key, they have to have the same denominator, you combine the numerators or denominator. You combine the numerators and put them over the common denominator. Must have the same denominator. Without the same denominator, you cannot use the rule. Okay, that doesn't mean you can't add the fractions. Something else has to be done. What you can do with fractions that do not have the same denominator is to use that fundamental principle of fractions that I mentioned earlier in the videotape and build fractions equivalent to each of the fractions that you want to add or subtract. Build equivalent fractions all having the same denominator, and then you'll be able to use this rule. Let's start with a simple arithmetic example. We would like to combine into a single fraction the following. Five, 6 minus 7/10 plus 11/12. Okay, we're going to add and subtract these fractions, and we notice they do not have the same denominator. So before we can do any work, we have to transform each of these fractions into equivalent fractions that have the same denominator. The question is, what denominator should we pick? Well, we try to pick the lowest common denominator possible. And in the videotapes on addition and subtraction of fractions, I explain in detail how one goes about finding the LCD, or the lowest common denominator. Let me briefly go over the idea here. To find the LCD, you factor each denominator completely into its prime factors. Okay, 6 is 2 times 3, 10, 2 times 5, 12, 2 times 2 times 3. You then take each factor the greatest number of times it appears in any one denominator. So we have 3 factors here, 2, 3s, and 5s. We look at 2. 2 appears once, twice, so we will need it twice. 3 appears once, no times, 1 time, so we will need it 1 time. The largest number of times it appears in any one denominator. 5 appears no time, 1 time, no time, so we'll use it once. You do not say there's a total of 2 3s and 4 2s. You don't add them up. You look in each denominator, and you take the factor the greatest number of times it appears in any one denominator. This will give you the lowest common denominator, which is, in this case, 2 times 2, 4 times 3, 12 times 5, 60. By this I mean we can build fractions equivalent to each of these, having the denominator 60. We want to transform each of these fractions to an equivalent fraction having this denominator 60. Now we're going to use the fundamental principle of fractions to do that. That says that it's okay to multiply the denominator of a fraction by a non-zero quantity as long as you multiply the numerator of that fraction by the same non-zero quantity. So we look. How do we go from 6 to 60? We multiply the denominator by 10. Well, if you want to build an equivalent fraction, that means you've got to multiply the numerator by 10 as well. Or it's 50 60ths is equivalent to 5 6. Same thing. Here, how do you go from 10 to 60 as far as multiplication? You multiply the bottom by 6. Therefore, you must multiply the numerator by 6 as well to get an equivalent fraction. And finally, How do you go from 12 to 60? It was multiplication by 5, so the numerator must be multiplied by 5 as well, giving us 50/60 now. 50/60 minus 42/60 plus 55/60. Now, I know we always tell you to reduce to lowest terms, but you must resist the temptation to make this 5/6 and to start simplifying. The whole idea here, these fractions are not in lowest terms. We are building larger equivalent fractions. We're building fractions with larger denominators that are not in lowest terms here so that we can combine. The whole trick is that we now have 3 fractions with the same denominator. We now combine their numerators and put them over the common denominator. 50 minus 42 plus 55 over 60. All right, 50 minus 42, that's 8. 8 and 55, that's 63 over 60. Now, if you'd like to reduce to lowest terms, fine. We notice that 3 is a factor in both the numerator and the denominator. The numerator is 3 times 21. The denominator is 3 times 20. We can cancel the 3's, giving us our answer as 21/20. Putting that fraction, combining these 3 fractions into a single fraction. All right. Our 9th example, also to combine 3 fractions, but now these are algebraic, not just arithmetic fractions. Combine into a single fraction. 2 over 3x squared minus 5 over 6xy plus 1 over 4xy cubed. To find the LCD, we will factor each denominator completely. 3x squared is 3xx. 6xy, 2 times 3xy. 4xy cubed, 2 times 2 times x times y times y times y. The LCD. Take each factor the greatest number of times it appears in any one denominator. So 3, once, no time, so we take it once. 2, no times, 1 time, 2 times, so we'll take it twice. X, twice, once, we'll take it twice. Y, no times, 1 time, 3 times, we'll take it 3 times. Giving us for our LCD 3 times 4, 12, x squared, y cubed. That's our LCD. In other words, we are going to build fractions equivalent to each of these fractions having the denominator 12x squared y cubed. (12x squared y cubed), 12x squared y cubed, 12x squared y cubed. And in each case, we're going to ask ourselves, what did we multiply the denominator of this fraction by to get this denominator? And whatever we did to the denominator, we're going to have to multiply the numerator by the same quantity. OK. We know we're going to have to multiply each of these numerators by whatever quantity the denominator was multiplied. OK, so to go from 3 to 12, we'd have to multiply by 4. To go from x squared to x squared, we'd have to multiply by 1. To go from 1 here to y cubed, we'd have to multiply by y cubed. So if you multiplied this by 4y cubed, you'd get the 12x squared y cubed, and that's what you'd have to multiply the numerator by as well. Same thing here. To go from 6 to 12, we'd multiply by 2. To go from x to x squared, we'd multiply by x. To go from y to y cubed, we'd multiply by y squared. OK. Here, to go from 4 to 12, we'd multiply by 3. From x to x squared, we'd multiply by x. Y cubed to y cubed, we'd multiply by 1. So we multiplied the numerator by 3x, because that's what the denominator was multiplied by. Let's see what we have. We're going to combine these numerators over the common denominator, which is 12x squared y cubed. I'm doing the combining and the simplifying of these individual terms all in one. 2 times 4y cubed, that's 8y cubed, minus 5 times 2xy squared, that's minus 10xy squared, plus 1 times 3x is plus 3x, giving us 8y cubed minus 10xy squared plus 3x over 12x squared y cubed for our final answer. The last 3 problems on this videotape I would like to spend solving solving fractional equations, simple fractional equations. Solve for x over 2 minus x over 3 equals 5, 6. Okay, now, there's a difference between this problem and what we've been doing earlier. We have been adding fractions. Oh, something like x over 2 minus x over 3 plus 5 over 6. Here we would combine, if we wanted to add these fractions, we combine over the lowest common denominator. Okay, we would combine over the lowest common denominator, which is 6. And we'd have 3 fractions, all with the denominator 6, and so on. In fact, your final answer would probably involve a 6 unless for some reason, you were able to reduce to lowest terms and got something else. But you would have still a fraction at the end. This is when you're adding and subtracting fractions. Now, by changing this plus to an equal sign, I have turned this into an equation. Okay, and the way we handle fractional equations is a little different. Basically, we say, look, we know how to handle first-degree equations without fractions. We would like to now handle one with fractions. And the best thing to do is simply to see if we can't transform this into an equation without fractions. And what we're going to do, since we do have an equation, is to multiply both sides of the equation. We are always allowed to multiply both sides of the equation by whatever non-zero quantity we choose. We're going to multiply both sides of the equation by the LCD, the same LCD we would have found if we were adding the fractions. What's going to happen is that each of these denominators, of course, is going to divide evenly into the LCD. So the result will be we'll get an equation without fractions. Okay, so when solving a fractional equation, we wind up with an equation without fractions. But when adding and subtracting fractions, we still get fractions at the end. Okay, now the LCD in this case is obvious. It's 6. This is factored completely 2. This is 3. This is 2 times 3. So taking each factor the greatest number of times it appears in any one denominator, 6 is the LCD. And what we're doing is multiplying both sides of this equation by 6. And in doing so, we're going to be using the distributive law. Okay, don't put the 2 into the 6 here, get a 3, and then have nothing left, say, to cancel over here. The best thing to do is actually do the distribution here. 6 times x over 2 minus 6 times x over 3 equals 5, 6 times 6. Now, let's do our canceling. Okay, if it helps you, you can think of this as 6 over 1. And then it looks more like our multiplication of fractions that we had earlier. Okay, 2 divided by 2 gives us 1. 6 divided by 2 gives us 3. So we have here 3x minus now 3 divided by 3 is 1. 6 divided by 3 is 2 minus 2x equals, here the 6's cancel, 5. 3x minus 2x equals 5. X equals 5 as our answer. And of course, we can check this in the equation. I'm not going to go through it, but it would be a very simple matter to go back to the original equation and to check this answer. Okay, the only important thing here is to find the LCD, multiply both sides of the equation by the LCD. In doing that, we turn this into an equation without fractions, which of course we already know how to solve. And be careful, if you have more than one term, to distribute, say, in this case, the 6 through both of the terms. Okay, in problem number 11, solve for x. X over 8 plus x minus 4 over 4 equals 1/2. The LCD in this problem is also fairly simple to get. It's simply 8. And we're going to multiply both sides of the equation by 8, the left side and the right side. Okay, this indicates that the distributive law is needed here. We have 8 times x over 8 plus 8 times x minus 4 over 4 equals 1/2 times 8. And you can think that this is 8 over 1, 8 over 1, and so on. Here the 8's cancel, leaving us with x. Here 4 goes into 8 twice, leaving us with 2 times x minus 4 in parentheses. 2 goes into 8 4 times. Okay, we now have a first-degree equation without fractions to worry about. And once again, we need the distributive law here. This is going to be 2x minus 8 equals 4. X plus 2x, that's 3x, minus 8 equals 4. We add 8 to both sides of the equation, giving us 3x equals 12. And from 3x equals 12, we can divide both sides of the equation by 3 to get x equals 4 as an answer. And you can, of course, go back to the original equation to check your answer. You would have 4/8 plus 4 minus 4 is 0 over 4, which is 0. 4/8 should be equal to 1/2, and of course it is. Okay, I'd like to do one more of these equations with you. Solve for x. X plus 1 over 3 minus x minus 2 over 6 equals 3/2. Okay, the LCD in this problem is once again 6. We're going to multiply both sides of the equation by 6. And doing so, we're going to use the distributive law here. 6 times x plus 1 over 3 minus 6 times x minus 2 over 6 equals 3 over 2 times 6. You don't have to put the 1s in, just to make sure you understand that we're really multiplying fractions here. 3 goes into 6 2 times. Here the 6's cancel. 2 goes into 6 3 times. Let's see what we have. We have 2 times x plus 1 minus, parentheses, x minus 2 equals 3 times 3, which is 9. Distributing the 2, 2x plus 2. Think of this as a minus 1 to be distributed. Minus 1 times x is minus x. Minus 1 times minus 2 is plus 2 equals 9. Combining 2x and the minus x gives us x. Plus 2 and plus 2, that's 4 equals 9. So x plus 4 equals 9. Subtracting 4 from both sides of the equation giving us a final answer of x equals 5. And once again, we can check this in the original equation. Let me do that one just to show you, since I didn't do the other two. The original equation was x plus 1 over 3, take away x minus 2 over 6 equals 3 halves. And we want to check x equals 5. Substitute in x equals 5. 5 plus 1 over 3 minus 5 minus 2 over 6 should be equal to 3 halves. 5 plus 1, that's 6 over 3 minus, now 5 minus 2, that's 3 over 6, should be equal to 3 halves. 6/3, that's 2. Take away 3/6, which is 1 half, should be equal to 3 halves. And if you think of 2 as 4 halves, 4 halves minus 1 half should be equal to 3 halves. You get 3 halves equals 3 halves, and it checks out. And that brings us to the end of this tape.